Okay, so day 2 of factoring is going to be about factoring trinomials, and you can see we have a flow chart that's going to tell us how we can go about factoring our trinomials. The very first thing is factor the GCF, which was our first day of factoring. That's what we did, was just factored the GCF. So we're going to continue to factor the GCF, but then we're going to follow these other steps. Okay, so what we're going to do is we're going to work a problem using this flow chart. So you might want to have the flow chart where you can look at it as we're going. I'll refer to it, but I'm not going to have it on the screen. I'm just going to have the problem that we're doing. Okay, so let's take a look here at the very first problem I have to work. Okay, it says we're going to factor this. Okay, so the first thing on my flowchart said factor the GCF. So I look this at my coefficients first, 3, 24, and 45. Okay, so somewhere off to the side or down below, I'm going to write 3, 24, 45. And then I look at my variables. I have x squared, x, and no x. The fact that this one has no x means my variables are not going to be part of my GCF if I have one at all. Okay, so 3 is factored into 1 times 3. 24 is 1 times 24. 2 times 12. 3 times 8. Okay, so here I notice that I have a 3 and I also have a 3. That's going to be my largest. So now I'm going to kind of check on 45. Does 3 go into 45? Let's see, 3 times... looks like 15 will give me 45. So that way I have all my 3's. I'm not going to write out every single factor at this point. So 3, 3, and 3. So 3 is my GCF. So just like yesterday, we're going to write down the 3. And then we put our parentheses. And then we go along and we divide each term by 3. So when we do that, we'll get x squared plus 8x plus 15. Okay, so that's factor the GCF, step 1 of our flowchart. Step 2 says to multiply the lead coefficient by the constant. Okay, so we're going to ignore this 3. That 3 is going to be part of our answer all the way down, but we're not going to write it every time. Okay, and so I'm looking here at my trinomial. My lead coefficient is 1, and my constant is 15. So I'm going to come over to the side and say 1 times 15, so that's 15. Okay, list the factors of the number. So 15's factors, that's 1 times 15. 2 doesn't go. 3 times 5. 4 doesn't go. 5 doesn't go. Okay, check our constant sign. The sign in front of our constant number is a plus sign. So since it's positive, we're going to add their factors together. So we're going to add 1 plus 15, and we get 16. We're going to add 3 plus 5, and we get 8. And it says we want the one that gives us the middle coefficient. So that's this set right here. Because our middle coefficient right here is 8, and that one added together to give us 8. All right, if the middle term is negative, so we look back up here. Is it negative? It is not. So we don't have to follow that one. Now we do what's called factor by grouping. Okay, so when we multiplied our binomials together to get the trinomial, we added like terms. So what we're doing right now is we're getting those 2 terms back out. So this, we would rewrite this as x squared plus 3x plus 5x plus 15. Okay, and now we factor by grouping. We take a group of 2 and another group of 2, and we look for, well, what's the GCF of this group? Okay. So we look out front, they have 1 and 3. So for as far as coefficients go, the GCF would be 1. They both have an x term. This one has an x squared, and this has an x to the first. So according to our rules, we'll take out the x, and then we divide it out. X squared divided by x is x. 3x divided by x is 3. Okay, so x times x plus 3 is that group. Okay. Now we look here. What do they both have in common? 5 and 15. Okay, well we factor 5 and we just get 1 times 5. 5 times 3 will give us 15. So we know that 5 is going to be our GCF. We look at the variables. This one doesn't have one, so only 5 is going to be our GCF. So we write our parentheses when we divide. 5x divided by 5 is x. 15 divided by 5 is 3. Okay. Now we notice that this says x plus 3 and this says x plus 3. That is now a common factor to both because it's being multiplied times both of these. So we can rewrite this as x plus 3 times x plus 5. Because if we take out the x plus 3 and we divide, right, we're left with x plus 5. Okay, so my final answer here is 3 times x plus 3 times x plus 5. That's completely factored, and that is utilizing the flow chart. Okay. Now, I like the flow chart just fine, but it gets a little complicated, and there's a lot of writing going on. So I want to show you kind of a modified flow chart that we can use. Okay, so let's look at this one. We're going to start the same. We're going to factor our GCF. Okay, so I'm looking 1 times 2, all of these are divisible by 2. So 2 is going to be part of my GCF. This has an x to the third, x squared, and x. So x is also part of my GCF. So then I divide it out. I'm going to divide each one of those, right, by 2x. So I get x squared plus 12x plus 36. Okay, now when we were multiplying our binomials, and got our trinomials, we used an organizational tool. We referred to it as a box. Some people called it a table, but basically we would have what we were multiplying on the outside, hence our factors, right? And then we would have these terms would be what ended up on the inside. And this, the first term, right, would be in the first box. The last term was in the last box. And these were our like terms. Okay? So I need to break apart the 12x again. Okay. So what we want to look for, right, and we did this a little bit, is our tower, all right, where we were multiplying up, we were adding up and multiplying down. Well, what we're going to multiply, right, we multiplied was the 36, because something times something, right, here gave us that 36. So we multiplied to get 36, and we added to get 12. Okay, and they're both positives, so that's what we're keeping there. Okay, so we're looking for, well, what numbers multiply to give me 36? Well, 1 times 36, 2 times 18, 3 times 12, right? 4 times 9, 6 times 6. All right, and because these are positives, right, we know we're adding them. That's part of our flow chart, so we're adding them together, and we're looking for 12. Okay, well, right here, 6 plus 6 gives me 12. So I know that my two numbers here would have been 6 and 6, which means over here I would have had 6x and 6x. All right, so now I'm looking for, well, what can I multiply together to go on the outside? Those are my factors. Well, the only way I can get x squared is if I multiply x times x. And then to get 6x, well, x has to be multiplied by 6. Okay, and that's a positive. Okay, and then same thing here, x times what gives me 6x? Well, 6, positive, and then I check the last box, 6 times 6 gives me 36. So my answer is 2x, because that's my GCF, times x plus 6, and then times x plus 6. And because mathematicians don't usually like to write things out like that, we're going to actually make this 2x times x plus 6 squared. Okay, so that's the most simplified answer right there. All right, let's try another one. So first we're going to look for our GCF. So 7 is 1 times 7. 15 is 1 times 15 and 3 times 5. And 2 is 1 times 2. So the only thing that they have in common coefficient-wise is the factor of 1. So that wasn't helpful. Then we check n squared, n, no n. Okay, so this one does not have a GCF at all. So we go to the next step, and that is to figure out what this used to be. Okay, so we're gonna take our box. We're gonna put 7n squared here. We're gonna put our 2 here, and then we're gonna figure out, well, what can we do to get 15? Okay, so we multiply our numbers, right? 2 times 7, so 14. That's what we're multiplying together. And then we want it to add up to 15. So how can that happen? Well, the only way we're going to get 14, right, is if we have 1 times 14 or 2 times 7. Okay, so when we add up, right, we're going to say 2 plus 7, that would not give me 15. 1 plus 14, however, would give me 15. So 1 and 14 here, which means I'm going to put 14 in here and 1 in there. Okay, because 14 plus 1 would give me the 15. Okay, so let's see if that worked out. So how can I get 7? Well, we know it's 1 times 7, so I'm going to have 7n and 1n to get 7n squared. And what times 7 gives me 14? Well, that'd be 2. So 1n plus 2. And then 1n times what gives me 1n? Well, 1. So that's plus 1. And then we check 1 times 2 is 2. So all of those work. So my answer is 7n plus 1 times n plus 2. You can write 1n if you want to, but it's not necessary. Okay. All right, let's check out one more example. If a rectangular envelope has an area of 2x squared minus 7x minus 4 square units, what are the dimensions of the envelope? Okay, well, it's a rectangular envelope, right? And its area is 2x squared minus 7x minus 4. Well, somehow these two boxes, right, combine to give me minus 7x. Okay, so to figure out what was in these boxes, I'm going to multiply my ends. So 2 times 4 gives me 8. Okay, and then what numbers multiply to give me 8? 1 times 8, 2 times 4, okay, and that's it. Now this is where it gets a little trickier because now we've got minus signs in there, right? And on our flowchart it said if our constant sign was negative, so now it is, it's a minus, then we're going to subtract these numbers. Okay, so I'm going to actually rewrite these, and because if I'm subtracting, I usually like my larger number to be first, my greater value. So 8 minus 1 and 4 minus 2. Okay, and so here I'd get 7, and here I would get 2. Okay, well, I have negative 7 as my coefficient, right? So in order for this to be negative, my signs actually need to be the opposite of what they are. So negative 8 plus 1 would give me negative 7. So I know this would be negative 8x, and this would be 1x. Okay, so now I'm looking, how can I get 2x squared? Well, I'd have to multiply 2 times 1 and x times x. Right? And how do I get negative 8x if one of my numbers is 2? Well, negative 4 times 2 gives me negative 8. And I've already got the x, so I'm good. Okay. And then I look at this box here, 1x, and that's also 1x. So I just need a positive 1 to make that happen. 1x times positive 1 is 1x. Negative 4 times 1 is negative 4. So that works. Okay, so the dimensions of my box are 2x plus 1 by x minus 4. You could also write x minus 4 by 2x plus 1. That would work too. Okay, so now you're going to complete Factoring 2 worksheet.